Hello, my name is Lindsay Simon, and now I'm going to walk you through the presentation on cascading style sheets. So, cascading style sheets, what are they for? Well, you can change things like text. You can change the color of text, the backgrounds behind text. You can change size, position on the page. Okay, so how do you get CSS onto your web page? Basically, there's three ways: inline, embedded, and external. And this is in order of easier to better. So inline CSS. Using the style attribute on an HTML element, you can embed a CSS declaration. Here we have color red to turn the text red. We're saying this is a bad practice generally because at this point you're now mixing the presentation CSS inside of your structure, which is HTML. Mixing these two creates a hard to maintain site, and it also means you can't take advantage of the cascade or reusing styles. Embedded CSS makes use of the style tag and allows you to put CSS in the content area here so that you can start using selectors, multiple selectors and declarations, usually put into the head of an HTML document, but it can be put in other places as well. This is okay, and it's good for developing a single page and testing things quickly. But you probably want to move your CSS ultimately to an external file using the link tag here, or you can also use the style tag with an import statement. But this allows your browser to download this file from the network, and subsequent pages could make use of the same style sheet and not have to re-download the text file of CSS. This can take advantage of network speed and also make your clients have a better experience by not having to go back to the network every time. So this can be cached in your browser. Okay, so how does CSS work? Basically, there's three parts to CSS. There's the selector, properties, and the values. In other words, first you select an element, you pick what it is you want to change about that element, and then what you want to change it to. In this case, we're going to make all paragraphs have blue text. This is the anatomy of a CSS object. You have a selector on the top followed by curly braces. Then you have the declarations, property value pairs, property colon followed by the value and the semicolon. Okay, done? Not exactly. Let's move on. Okay, so part one, we're going to talk about the syntax in CSS in more detail here. Make sure you really get it. Selector, the thing before the curly braces in that anatomy page we just saw. So there's four ways to select in CSS. You can select by an element, in other words, by its tag name. You can select by class, ID, or position in the document. So by element here, this says select all the paragraph elements in the entire document, anywhere on the page. If you say .help, this selects any element with the class name help, the dot being how you say this is a class name. Or by ID, if you use the pound symbol, that says select any element with the ID about. IDs are unique, so only one element in your document should have an ID of about. In this case, this is very specific selector. Or by position in the document. And here we're going to make use of a tool called the select oracle, which is fun to use and allows you to paste in a CSS selector and get back a text description of exactly what that selector means. So here we pasted this selector with the bottom pound about space P into the select oracle, and we've also put a snippet of HTML at the top to give it even a visual example of what this might be like. But this selects any P element that is a descendant of any element with an ID attribute that equals about. So looking at the HTML above, this selects the P's, the two that are highlighted within the div that has an ID of about. Notice it does not select the P tag that comes afterwards because they're not inside. So this is called a descendant selector. The space after the word about here is very significant. That says a P anywhere within a div, an element with the ID of about. So this, in this case, is just the first child, but it could be deeper into the hierarchy. Any P anywhere within that element. So here, p.intro This selector selects any p element with a class attribute that contains the word intro. So notice the lack of space after the p. This selects paragraphs only that have class that contains the word intro. So it only selects the first p in this case, as you can see above. And here's a really long selector. And to some extent this one is sort of done for learning purposes, but it's not an insane selector. You could see this on a page. So it selects any m element with a class attribute that contains the word required, that is a descendant of a p element, that is a descendant of a form element, that is a descendant of a div element with a class attribute that contains the word content, that is a descendant of any element with an ID attribute that equals header. This would be a heavy selector on your browser because all of these descendants would require a lot of matching. Challenging for your browser to perform. A subtle point here, you notice that in the paragraphs before this we said a class attribute that contains versus an ID attribute that equals. This is important. In CSS, the class attribute can take multiple classes separated by spaces in HTML. So the value here, help space intro, is interesting. This will apply to CSS classes if they're defined. So we have .intro, which says the background should be green, and .help, which says that the color should be red. So in this first P, both match, and so both are true, and you get text that is red with a green background. In the second one, only the help selector applies, and so the text is red. There is one more type of selector called a pseudo class. Notice the colon after an element here, which these are used to communicate state, and you've probably seen this before, most notably on the anchor to talk about its link state. In other words, a link that you haven't visited, a link that you have visited when you hover over that link, and then when you're clicking, you're selecting it. All right, now onto the declaration. In other words, the thing between the curly braces. Here you have property value pairs. So it's the combination of a property and value. You declare what it is you want to change and how you want to change it. CSS has an enumerated list of the things you can declare. For example, font, or color, background color, or border. These are called properties. And every property has a set of values that can be applied. Font, for instance, has 12px space normal space Verdana, comma, sans serif. And that sets a variety of individual parts of the font. Color here, there are 3 ways to set color. There's hexadecimal, #123. There's a system color called red, which is a text string. There's also RGB, which you can give values inside of parentheses. Properties come in different granularities, so you probably saw that in the font example before, but border is an interesting example. Border, by itself, you can set, or you can set all of these granularities on border. You can set just the border right's color, or its size, by width. Or font, for instance. There's the family, size, style, variant, and weight. The simplest variation of granular property is called its shorthand. So for instance, border : 1px space solid space #000 is the same as setting the border width, style, and color. When using shorthand, the order that you set these values is significant. You can't set them in any other order, so you just have to memorize that. With granularity, you can change specific parts of an element's style. So, for instance, on a page, if you set all the P's to have a border of 1 pixel solid red, and then for just the ones with a class name of intro, you just want to change their border color to be blue. This is nice because now if you want to suddenly change all your borders to be 2 pixels, your intros will also become 2 pixels. It'll inherit the 1px size and the solid color. But you end up with the ones that'll be blue. All you're changing is color. So, what size is any P's border? They're all 1 pixel in this case, but intro is blue. Okay, now we're going to talk a little bit about units, because you've seen us using 1px in some of these examples. And units are how CSS measures things. Namely, there's 2 types of units in CSS. There are absolute units and relative units. For instance, you have the px, or the m, or the percentage. Absolute units. Pixels are absolute units. They're always the same size. On any screen, 1 pixel is 1 pixel. It could be your phone, it could be your browser. Relative units, For instance, the M. M is always relative to the current value of font size. So when you say width of 2M or font size 2M, that says take the current font size, get its calculated value, and then make it twice that value. It's sort of like saying 2 times the current font size. And it always requires that you get the current font size and then multiply it by the number you use of M. Which is like percentage, although percentage is relative to different things in different contexts. For instance, you can say width 50%, and that says 50% of the available width. But, as before, you can also say font size 50%. In other words, 50% of the current font size. This is exactly the same thing as saying 0.5 M. So, relative units are calculated. If here you set the body's font size to 12 pixels, everything within the body is now 12 pixels. So, you want H1s to be bigger, so you set their font size to be 200%. So now, any text anywhere inside that H1 is 24 pixels. 12 times 2, 200%. So now if you set A's inside of H1 to have a font size of 75%, this goes and calculates that it gets its current font size, which is 200%, or the 12 times 2, and now multiply that by 0.75, and you get the current font size for anchors inside of H1 to be 18 pixels. Okay, pop quiz. What if the body's font size is 12 pixels? H1s are 200%. But now the body has been increased to 14 pixels. What size is H1 in pixels? Okay, this is easy, it's 28. And what's nice about that, as you can see, is that if you set a baseline font size for your document, and then set all your other font sizes to be relative, if suddenly one day you decide, I want all my text to be just a little bit bigger, all you have to change is your baseline size. Everything else will just inherit that and grow accordingly. So everything stays fluid and relatively sized to itself. Alright, we're going to have a little diversion here on typography. So what is this thing called an M? You notice we were talking about it being relative to font size. So this comes from an old typography setup when we used to cast things for print presses, and you have these metal casts. So here, C refers to the M size. And this is just kind of fun. This comes from Wikipedia. So 1M is sometimes said to be equal to the width of a capital M in a particular typeface, as the M was commonly cast the full width of the square blocks, or M quads, also mutton quads, which are used in printing presses. So in modern typefaces, the character M is usually somewhat less than 1M wide. Moreover, as the term is expanded to include a wider variety of languages and character sets, its meaning has evolved. This has allowed it to include those fonts, typefaces, and character sets which do not include a capital M, such as Chinese and the Arabic alphabet. Thus, M generally means the height of a font in question. So that's where the term comes from. Font family. If you're not familiar with different kinds of fonts, these come from your operating system when you're using a web page. But as you can see, here's an example of Courier, or there's an example of Georgia, or Trebuchet. There are a variety of fonts, but they're all dependent on what's on your operating system, your user's operating system. Generally, there's a generic catch-all for fonts. There are those in the family of serif and those in the family of sans serif. And what's a serif? A serif is this little squiggly line right here on the edges of the character that you see. So if you look at the R here versus the R here, this is without a serif, sans meaning without. In print, it's generally thought that serifs make text more readable, but on the web, we generally think sans serif is more readable. Okay, back to the technical stuff. Cascade. So this is the first part of the C in CSS. The cascade determines which declarations apply to any given element. So basically, things are applied in the order you define them. So here we have P, color is red, followed by a declaration which says P, color is blue. So the last one wins. What color is P? All P's are blue. Saying the last declaration wins is actually kind of a lie. The way you'd say it truly is the last and most specific declaration wins. So here we look at these two examples with our markup. Here's one that comes before, £A space £B space H1, color red, followed by £A space H1, color blue. Which selector do you think is more specific? And what color is an H1 inside of £B? Well, in this case, it's the first one because it's more specific, even though the second one comes after. If we were talking about the H1 inside of pound B, it would be red. So fortunately, this isn't just use your intuition and pick which one looks the most specific. There's a point system. The point system says an element selector is worth 1 point, a class selector is worth 10 points, and an ID selector is worth 100 points. So for instance, a p space a selector is 2 points. p.intro space a is 12 points. Here we have 2 element selectors and 1 class selector, so 1 plus 1 plus 10 is 12. This last example is the same except that we've added an ID selector, so we have 112 points. Notice that it's significantly more powerful than the selector above it. Alright, now we're going to talk about inheritance. So elements inherit styles from ancestor elements. For instance, here, if we say an element with the ID of blog is colored red, all text inside an element with ID blog is now red, including that P right there. Its text will be red, even though we didn't set P's text color red. In other words, it's inherited from its ancestor, the div with ID blog, the text color. Sounds easy enough, right? Okay, not quite all of it. Basically, text-related properties inherit, but layout-related properties don't. So, this is a table, for example, of text-related versus layout-related properties. All the ones on the left will inherit, whereas the ones on the right will not. And that's handy. As you start to write CSS, you'll come to appreciate that margins and paddings and borders don't inherit on elements, but the text-related properties do, so you don't always have to define them. Which brings us to part 2, layout. So we have the first section here, we'll talk about the box model, part 2, display, 3, position, and 4, float. So the box model. The box model is a very important concept in CSS. And at Google, we actually did a poll of front-end engineers to see if there was one thing that everyone could understand about CSS, what would it be? And we decided it was the box model. So the box model is content, padding, border, and margin. And every box has these 4 properties. And it looks like this. Essentially, content. You can think of content as the text inside of an HTML element. So that's where you have your content. And when you set something like width, that applies to the content only. But outside of that, you have a space for padding on all 4 sides of a box. You have an area for border on all 4 sides and an area for margin on all 4 sides. When you set backgrounds, that happens inside of the border and includes the padding and includes the content. It does not include the margin. So what does it look like to declare margin or padding on the box model? For instance, here at the top we say margin colon 1em. That sets all 4 margins around the box to be 1em in size. In the second example we have margin colon 1em space 2em. The first rule here says 1em on top and bottom, 2em on left and right. And if you wanted to set all 4 sides of the box, you could say 1em space 2em space 3em space 4em. And that sets top to be 1em, right to be 2em, bottom to be 3em, and left to be 4em. And basically this is clockwise from the first setting, so it goes top, right, bottom, and left. Display. So display is a very important property in CSS. And there are 2 values for display basically, inline and block. Actually, there are a whole lot of values for display, but we're going to talk about inline and block, because if you can understand them and their influences, you'll understand a lot about CSS and what's happening on your page. So inline boxes. Basically, inline boxes go with the flow. Inline boxes can appear next to one another and flow along the right-hand side of boxes on their left, or if you're in RTL mode, the other way around. But here, you can think of this as anchors or spans or image or input. These all can appear next to one another. Span is the generic inline display element. So you can also think of this as text. When you have a paragraph with a bunch of text inside, every word itself is actually rendered as a box by your browser, and it's rendered as an inline box, also called an anonymous inline box. Even though you didn't put a tag there, it still has to have a box around it. block. Block boxes need their space and take up their own line. Some easy examples here are the H1, the P, the UL, the LI, or the div. The div being the generic block display box, or division. And it just says they want to be on their own line. Elements which come after have to be on their own line, vertically. So, in this example, what if inside of a P we have the text please search, with search being inside of an anchor. And so, as you can see below, it renders inline, please search. But what if you set anchors to be display block? You get please followed by a new line and then the word search. The other way to get this effect might be you might think to put a break tag after the word please. But notice that here, just by using CSS, we achieve the same effect without polluting our structure at all with something like a break tag. And we get the effect we wanted. This is a common used technique by people comfortable with CSS, and I urge you to try this on your pages. You can change display for any element. Position. Position's another property. Static being the default. Relative is a position, absolute position, and fixed position. These are examples which you'll see more in the CSS walkthrough, which comes after this, and makes a lot more sense seen visually. Float. Float can be confusing, but also makes more sense seen in the exercise, which is immediately following here. So, that's it. Pretty simple, right? You're all CSS experts. Congratulations. One last part. For browser support. Everything we've talked about so far is covered by CSS1. CSS2 gives us a little bit more interesting syntax around how you can write selectors, and is worth looking into. We've talked about descendant selectors primarily, and then element plus class selectors. But there's some other interesting selectors like first child selectors, selecting more interesting positions in the document. And there's even CSS3 with its great property values which allow you to do things like rounded corners without images. But everything you've learned so far will be supported in all browsers. But as you get further in your wizardry of CSS, start reading the specs for CSS3. And that's it. On to the CSS walkthrough section, and I hope this has cleared some elements of CSS up for you.